All right, so 7-1 had ratios, they had proportions, properties of ratios, and they had like your little word problems, right? So a refresher on 7-1, which is the ratio is the comparison of two quantities by division. It can be written as A to B with a colon in between, A with the word to between, or A over B. The biggest thing here is that the units are written in the same unit. So if it was inches and feet, we convert them to be the same unit. And then we always simplify a ratio, right? We remember ratios? Yes? Oh, I hit the wrong thing. All right, so in front of you is a question that says the painting measures 5 feet tall by 3 feet 4 inches wide. What's the ratio of the length to the width of the painting? You can write on this. This is a written one. So go ahead and do it. It's just like class cake. God bless you. I don't know if you can actually.
You can.
Yeah. Nope. You got to do first. Yeah, you got to convert them so they're the same inches, same unit, right? And I always change the larger unit to the smaller unit. So not the other way around, you're going to end up with like decimals within your fractions. You don't want that stuff, right? So if I had something that's 5 feet, how many inches is that? 60 inches. And then if I have something that's 3 feet, 4 inches, the 3 feet becomes 36 plus the 4, that means that's 40 inches. It says length to width, right? Which is the width is the shorter one, which is the one that comes second. So I would do length, which is 60, to width, which is 40. And then you have to simplify it. So the easy thing here is to cross out the zeros. And then I get 6 to 4, which they're both divisible by 2. That becomes 3 to 2. So that would be the ratio of the length to the width of the painting. If it had said width to length, I would have reversed it. I would have done the 40 over the 60, so pay attention to the order of the words.
You can't simplify them like by dividing by something, like if you did it by 2, it would be like 30 over 20.
Huh?
Zach instead of crossing out,
It would be
just
3
divide by
over 2. Oh yeah, okay, yeah, then it would be 3 over 2.
Yeah. You can simplify in any order as long as you're dividing both the top and the bottom by the same thing. Yeah. You had me totally confused for a minute there, David. Okay, all right. All right, so we said when we have two ratios equal to each other, we're going to cross multiply. I'm going to do 6 times x plus 2 equals 5 times 12. I distribute this to both, which is the mistake some of you made not going to both. 6x plus 12 would equal 60. Subtract the 12. 6x would equal 48. Divide both sides by 6. And x is 8. Some of those questions gave us decimals or fractions. As long as they're simplified, it would be fine. Okay, some of them whole numbers, but not all of the time. Questions on that one? Yep.
When you put 6 and then the parentheses x plus 2
Yeah.
equal to, why is it equal to 5, not 6?
Because you go the x this way and this way, right? So if it's x plus 2 over 12 equals 5 over 6, I multiply these two together and set it equal to those two. Yep, Michael.
Where did you get the 12 from? From 6x?
I distributed the 6, so this was in parentheses, right? That 6 has to go to both the x and the 2. And I would say that's probably one of the most common mistakes that people made on the quiz was not distributing it to both. You got to distribute it to both. That 6 gets multiplied by both the things that are in that top corner. You could take a proportion like A over B equals C over D, and you could change it by flipping it upside down, making it B over A equals D over C. You could also take it and go left to right with your numerators. So if I had A over B equals C over D, then I could go left, right, which would be A over C equals left, right, B over D. And then the third thing you can do is add the denominator on. So if I did A plus B over B, it would equal C plus D over D. So those are the 3 properties that you can do with a proportion, right? Flip it so they're both reciprocals. Go left, right in the top and left, right in the bottom. Or add the denominator to each of them. You remember this? Yes? This is also on your quiz, right? Okay. So if it says x over y equals 2 over 3, there's 3 ways I can change this. One is flip them. So it would be y over x would equal 3 over 2. If I flip the one on the left, I gotta flip the one on the right, vice versa. The other way to do it is to take it and go left to right. On the numerators, left to right in the denominator. So that would be x over 2 equals y over 3. And then the third way is the denominator addition. X plus y over y would equal 2 plus 3 over 3. That one reduced to 5 over 3. Understand? Yes, because if each of those are a test question, those are easy ones to get right. Then came 7-2, and 7-2 is similar polygons, actually. So this is where we looked at these polygons of any number of sides. And we said if they're similar, then they're not congruent. They're not the exact same shape and size, but they're almost like a little mini-me version of one or the other. So if I looked at what was there, right, if I look at the left one to the right one, I can say that the angles match up. Angle A would equal angle M, D and P and C and O. And then I can say the sides are proportional. So I could say AB over MN would equal BC over NO equals DC over PO equals AD over MP. Then we talked about scale factor, right? So scale factor is the measure of one side that corresponds to the other side as simplified as it gets. So if I ask for the scale factor in this case, if I ask for the scale factor of the big one to the small one, it would be 12 to 6 or 2 to 1. If I asked for it to be MNOP to ABCD, then it would be 6 to 12 or 1 to 2. We remember scale factor? Yes? Did it go? I don't want to have it too many times and it not go. Okay, so it said, are the polygons similar? And if they are, write a similarity statement and give it a scale factor. If you look at the shape that's there, let me see how zoomed in I can get. There we go. If I look at the shape that's there, right, I need to figure out if in order for them to be similar, all 4 pairs of sides have to simplify to the same ratio, and then all 4 pairs of angles have to match up. I've got a right angle that matches a right angle, a single arc that matches a single arc, a double arc that matches a double arc, and there's only one left over. If I add them, subtracted from 360, it's always going to be the same. So there's only one left over and the others match, it's going to match. So then I have to set up the ratios. So the biggest side and the one on the left is 15. It's repeated, but there's 2 12s, right? So if I said 15 to 12, it's supposed to equal 15 to 12, which obviously does. Then if I went in order of smallest to largest, the next one down would be 10 on that one on the left. The next one down would be 8 on the one on the right. And then on the left, the smallest side is 7.5, and on the right, the smallest side is 6. So if these are similar, then all of those ratios have to be simplified to the same thing. What goes into both 15 and 12? 3, right? This would be 5 to 4. This would also be 5 to 4. What goes into both 10 and 8? 2. That would be 5 and 4. 7.5 over 6 becomes 75 over 60, or you could have just multiplied by 2. Either way, this reduces, right? 15, well, let's do 5 first. 15 and 12, which is 5 to 4. So they all reduce to be the same things, which means they are similar. And then it says write a similarity statement. So I have to say polygon, let's say I go P, let me see the order that I asked you, actually. Okay, so no is obviously wrong because we know that they're similar. Then it said POSN to KDAG. And then it said scale factor. And one scale factor was 5 to 4, one was 4 to 5. Pay attention to what you're doing. If you're saying POSN, that's the bigger one, right? To KDAG, that's the smaller one. That scale factor would have to be 5 to 4, not 4 to 5. So just make sure you pay attention to the order that they're asking you because that will determine which order you put your side lengths. Questions? A lot of you got that wrong. Do you understand why? Yeah? All right, then came 7-3. 7.3 was 3 methods to proving the triangles are similar. Now we're talking about triangles. We had 3 methods: angle, angle, similarity, side, angle, side, similarity, and side, 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 similarity. Angle, angle is if you have 2 pairs of angles that are marked as congruent. That's enough information to show that the triangles are similar. Then we had side, angle, side, similarity, which is 2 sides proportional, 1 angle where they meet congruent. And then 3 sides is if you had all 3 side lengths and you put them into ratios and all 3 of them simplified to be the same thing. So 3 ways to prove that they're similar. All right, question 1 said, are the triangles similar? And the triangles look like this. Do I have any information about angles? So if they are similar, I'm going to rule out angle, angle, or side, angle, side. I know nothing about the angles, right? Which means the only way I can prove that these are similar, if they are, is side, side, side. So I'm going to test side, side, side by doing 12, largest side, so 12 over 4. Middle side should be, I pause it. Middle side should have been 9 in the one on the left to 3 on the one on the right. And then the smallest side on the left is 8, and on the right it's 2. So the question is, do these reduce to be the same thing? 12 over 4 becomes what? 3 to 1, right? 9 over 3 becomes 3 over 1, and 8 over 2 becomes 4 over 1. Are those the same thing? No, so that's why these are not similar, okay? Just because it gives you all 3 side lengths doesn't mean they're going to reduce to be the same thing. All right, now this is like matching. So you got to match which one goes with which. All right, if they are similar, and remember the order of the letters is important, then the first one, which is H, would match the first one, which is C. Second one, which is J, would match the second one, which is N. Third one, which is K, would match the third one, which is D. Order is important. And then the sides, HJ, first 2 letters would go over CN. Second 2 letters, JK, would go over ND. And first and last HK would go over first and last CD. Easy stuff, right? That should be another easy question. If it's drawn this way, right? If this is Q, this is S, this is R, this is P, then this right angle tells me this is the hypotenuse it's referring to. The whole hypotenuse on the big triangle. Allison, can you tap her, please? So it says again to figure out what the similarity statement is. A similarity statement is what is similar to what is similar to what. So that's, each of these are similarity statements. But you got to figure out which of the orders is right. So if I look at A, it says YHB. YH is the middle length side of that big triangle, and HB is the smaller. So I'm going mid to smaller on that. So then when I look at the second one, I want to go mid to smaller. So YD is the middle length side. DH is the smaller side. That one works. And then I want to go middle length, which would be HD, to smaller length, which is DB, HDB. So that first one's the right one. Does that make sense?
Yes, ma'am.
Okay, then came what's the geometric mean of 6 and 16. So geometric mean, I say the square root of 6 times 16. This is 2 and 3. This is 4 and 4. I could keep going with those 4s, but one already repeats. So the 4 goes to the outside, the 2 and the 3 stay underneath, and I get 4 root 6.
That's actually the easiest part. Yes.
Yep.
How do you do that?
How did I get 4? So I took 16 and broke it down. It's 4 times 4. That means 2 4s, 1 goes to the outside. If you keep going, you'll get 4 2s. So you can also bring out 2 2s. It would be the same answer. Next one said, what's the value of x? So on this one, x is located on what part of the triangle? What's that part called? The side, which is also called a what? Think about it in terms of altitudes and legs, right? Is that an altitude or a leg? The leg. So we're going to use leg, or we're going to use hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. The hypotenuse of the big triangle, I'm going to add the 12 and the 4, which is 16. The leg is x. The leg is x over the segment of the hypotenuse adjacent to the leg, which is 4. I get x squared equals 4 times 16. 16 is the whole hypotenuse, so you have to do 4 plus 12. X equals square root 4 times 16. 4 is 2 and 2. 16 is 4 and 4. That's 2 2s. That's 2 4s, which means it's 8. Please.
Wow, the attitude.
Last one. Now we're solving for y, right? Y is on what type of segment in that triangle?
12.
Y is what type? What name is that segment?
That's
The y is the altitude. So I use segment 1 over altitude equals altitude over segment 2. Segment 1 and 2 does not matter. You just can't use the same one twice. So I can say 4 over y would equal y over 12. Y squared equals 4 times 12. And then y equals the square root of 4 times 12. That's 2 and 2. That's 2 and 6, which is 2 and 2. Each pair of the same number brings 1 to the outside. And there's a 3 that's left without a partner, so it's 4 root 3. Okay, so that's not every single type of question that's on your test, but it's a good chunk of them. You can, right,
How do I get out of this?
you should be able to, let me double check. If you air up, well, kick submit. You gotta hit submit on that last one.
I don't have this submit. Am I supposed to pick more than answer?
So you're stay in your seat for a moment, just for a moment. Listen, your chapter review, okay, will be the PDF of the questions on Canvas. That is due tomorrow. If you are going on Antioch, then you're missing basically the day 2. Like, I'll go over the questions from it. I will also record that. So tomorrow you're coming in. Yeah, is it just you?
Yeah.
Okay.
Oh, you're a leader?
So tomorrow when you come in, we're going to go over the questions in that book. And then again, your test on 7-1 to 7-4 is Thursday, which is the day after.